Welcome to the deep dives. Ready for a real head scratcher today? We're going to dive into this wild theory about something called a pole shift. And you know what else? We're going to see if it could maybe explain what's going on with the Greenland ice sheet.
Yeah, you heard that right. Like, what if Greenland was in a totally different spot on the globe way back when?
Huh. A different spot, you say. Well, let's not get ahead of ourselves. But the idea that Earth's geography has, been pretty radically different in the past, that's something scientists actually talk about seriously.
Okay. Before we, totally lose our bearings in the Arctic or something, if you guys are loving these deep dives into the unknown, do us a favor, hit that like button and subscribe to the channel. Trust me, you won't want to miss what's coming next. All right.
Okay, so imagine this Greenland, a land whose name literally means Greenland, covered in ice. An ice sheet that's almost 2 miles thick in some places.
It is kind of a paradox, isn't it?
It is. It really makes you wonder, why is it there? What's the story behind all that ice?
Well, that's what we're going to explore today. We're diving into the fascinating and some might say controversial theory of pole shifts.
Pole shifts. Wait, you're talking about the Earth's axis actually shifting, like a wobbling, spinning top.
Exactly. Now, I know it might sound like something out of a science fiction movie, but there's actually a growing body of evidence that suggests that these shifts have occurred in the past, and they could have had a dramatic impact on the distribution of ice on our planet.
Okay, I'm intrigued. But before we go any further, let's back up a bit. What exactly causes a pole shift? I mean, we're talking about a planet, right? Not some tiny little toy.
Right, well, it all comes down to the dynamics of Earth's interior. You see, the Earth isn't just a solid ball of rock. It has layers, and deep down at its core lies a molten iron core. This core is constantly churning, generating a magnetic field that surrounds our planet. But this core isn't static. Over vast stretches of time, the movements within this core can cause the Earth's rotational axis to drift.
So it's like the Earth is doing a slow cosmic dance, and sometimes the music changes and the dance steps get a little wilder.
I like that analogy. Now, the time scale for these shifts can vary. We're talking about processes that can unfold over tens of thousands or even millions of years. But there are researchers who believe they've found evidence of more rapid shifts, and that's where things get really intriguing.
Right, spill the beans. What kind of evidence are we talking about?
Well, some researchers point to the work of Charles Hapgood, a scientist who proposed that massive crustal displacements have occurred throughout Earth's history. Hapgood argued that these shifts could happen relatively quickly, within a matter of decades or even years.
Wait, decades? Years? That's not exactly the slow and steady crawl we were talking about before. What would cause such a rapid shift?
Hapgood proposed that the accumulation of ice at the poles could actually create an imbalance in the Earth's rotation, eventually causing the crust to slip, kind of like a loose button on a spinning shirt.
Okay, that's a pretty vivid image. So the weight of all that ice could actually be enough to throw the Earth off balance.
Exactly. It's a controversial theory, but it's certainly a thought-provoking one.
I'll say. But if Greenland was once in a warmer location and a sudden shift caused it to move to the Arctic, wouldn't that have had a dramatic effect on its climate and the formation of the ice sheet?
Absolutely. A rapid shift could have plunged Greenland into a deep freeze, leading to the rapid accumulation of ice. In fact, some researchers believe that the Greenland ice sheet might have formed much more quickly than previously thought, potentially due to a sudden shift in its location.
Okay, my head is officially spinning.
Well, imagine this. Millions of years ago, due to these internal shifts within the Earth, Greenland was positioned at the North Pole.
Wait, you're saying Greenland, the landmass we know today, was once located at the very top of the world?
That's the theory. Now, at the pole, you have extended periods of darkness and temperatures that are consistently below freezing. Those are the perfect conditions for a massive ice sheet to form.
Okay, so picture Greenland, smack dab at the North Pole, just piling up ice for eons. Then what happens?
Then, over a very long period of time, the Earth's axis gradually shifts, and Greenland is carried away from the pole to its current location. But the massive ice sheet, formed over millennia, remains. It's a relic of a time when Greenland was the king of the polar domain.
Okay, that's pretty mind-blowing. But is there any evidence to support this theory? I mean, besides a giant ice sheet sitting on what seems like a relatively warm island?
Well, one of the most compelling pieces of evidence comes from ancient fossils. Fossilized remains of tropical plants and animals have been found in polar regions, including the Arctic.
Hold on. Tropical plants in the Arctic? That doesn't sound right.
It does seem strange, doesn't it? But these fossils suggest that these regions, now locked in ice, may have once enjoyed much warmer climates.
So we've got misplaced tropical plants hinting at past climate shifts. What other clues are there?
Well, there's the work of Charles Hapgood, a Harvard historian who proposed a theory called Earth crust displacements.
Wait, wasn't that the guy who had Albert Einstein backing his ideas? Now that's impressive.
You're right. Einstein was fascinated by Hapgood's work and even wrote the introduction to one of his books.
So Einstein gave it the thumbs up. What exactly was Hapgood proposing?
Hapgood's theory suggested that the Earth's crust isn't actually fixed. It's capable of shifting, almost like a loose skin on an orange. He argued that these shifts could happen relatively quickly, geologically speaking, causing entire continents to move dramatically over the Earth's surface.
So we're not just talking about the slow drift of continents over millions of years, like continental drift. This is something far more dramatic.
Precisely. Hapgood believed that these crustal displacements could be triggered by various factors, including the gravitational pull of other celestial bodies.
Okay, so imagine the Earth's crust, this massive jigsaw puzzle of continents, suddenly rearranging itself. It's kind of like shaking up a snow globe. Everything changes in an instant. But how does this connect to Greenland and its icy crown?
Well, if Hapgood's theory is correct, it means that land masses, including Greenland, could have moved across different climate zones throughout Earth's history.
So Greenland could have been basking in tropical sunshine at some point and then got a one-way ticket to the Arctic Circle, bringing its icy souvenirs along for the ride.
Exactly. And Hapgood wasn't just theorizing, he presented a lot of evidence to support his claims.
Like what? Give us the juicy details.
Well, one of his most compelling pieces of evidence came from ancient maps. He discovered maps dating back centuries that depicted land masses, including Antarctica, with surprising accuracy.
Wait, you mean maps of Antarctica before it was officially discovered? That's rewriting history right there.
Exactly. Hapgood argued that these maps could only have been created if the map makers had access to knowledge of Earth's geography from a time before the supposed crustal displacements occurred.
Okay, so we've got ancient maps hinting at a lost world. What other evidence did Hapgood uncover?
He also looked at what are called erratics. These are large boulders that are geologically out of place, found far from their presumed origins.
So like finding a giant chunk of granite in the middle of a desert, miles from any mountains, that's an erratic.
Exactly. Hapgood argued that these erratics could have been transported vast distances during crustal displacements, almost like pebbles carried along on a giant rushing river.
All right, so we've got tropical plants in the Arctic, ancient maps depicting lost continents, and giant boulders scattered across the landscape like misplaced marbles. This is starting to sound like a real-life Indiana Jones adventure.
It does, doesn't it? And we're just getting started. The evidence for these Earth-altering events goes even deeper, leading us to the field of archaeorientation.
Archaeo, what? Are you going to have to break that one down for me?
It's essentially the study of how ancient structures were oriented and aligned, and what that might reveal about the Earth's past. We're talking about structures like pyramids, temples, those massive stone circles, all sorts of ancient wonders.
So you're saying that the way these ancient structures were built, the direction they faced, could hold clues about past pole shifts.
Exactly. And some researchers have found some really interesting correlations. They've discovered that the alignments of some ancient structures seem to point to different positions of the geographic poles throughout history.
Wait, you mean these structures were built when the poles were in different locations? It's blowing my mind right now.
It is a pretty radical concept, but if a pole shift can move continents, it certainly makes sense that it could also affect the orientation of structures built on those continents.
Okay, we've got pyramids pointing to lost poles. Now that's what I call a historical plot twist.
And what's even more interesting is that these archaeorientation studies seem to support some of Hapgood's ideas about crustal displacements. They suggest that the Earth's surface has undergone some pretty dramatic transformations over time.
This is seriously making me rethink everything I thought I knew about Earth's history. It's like realizing that the ground beneath our feet isn't as stable as we think. But hold on a second. We've been talking about pole shifts in the past. What about the future? Is there any chance of another pole shift happening in our lifetime?
That is the million-dollar question, isn't it? And it's one that scientists are actively investigating.
So no definitive answers yet.
Not quite. But that's where things get really interesting and, well, maybe a little bit unnerving.
Deep divers. Sounds like we've arrived at a cliffhanger. To find out what a future pole shift might have in store for us, you'll have to join us for part 2 of this epic deep dive.
Yeah.
Stay tuned.
Welcome back, deep divers. Are you ready to explore the what ifs? What if a pole shift were to happen in the, say, not-so-distant future? What would that look like for us?
I know we left everyone hanging last time, so yeah, let's dive right into those potential consequences.
All right, well, picture this. The Earth's axis shifts, and suddenly, everything we thought we knew about climate and weather patterns is thrown into chaos.
So no more of the same old weather complaints. We're talking a full-on climate makeover.
Oh, yeah. We could see places that were once temperate experience wild swings in temperature. Areas known for being fertile breadbaskets might turn arid.
Wow, that's a pretty extreme makeover, like flipping the script on the planet's climate. But let's get practical for a second. How would these shifts actually affect us?
Think about something like agriculture. The regions that provide the bulk of the world's food could become completely unsuitable for farming. Imagine the strain on global food supplies, the potential for famine on a massive scale.
That's a chilling thought.
Yeah.
So not only is our climate going haywire, but we might not even be able to feed ourselves.
And then there's the impact on sea levels. As the Earth's crust shifts and ice sheets start melting at accelerated rates, we'd see both rising and falling sea levels in different parts of the world. We could be talking about entire coastal communities disappearing under the waves, mass migrations and displacement unlike anything we've ever seen.
Okay. Things are getting a little intense here. But it's important to remember we're still in the realm of what-ifs, right?
Right. But sometimes those what-ifs are a good reminder to think about how interconnected everything is. One shift in one place can have ripple effects that spread across the entire planet.
You're saying this isn't just some far-off problem. This is something that could affect all of us.
Exactly. And it goes beyond climate, agriculture, and sea levels. We also have to think about the potential impacts on things like technology and infrastructure.
I'm listening. Give us the breakdown.
Take our reliance on things like GPS, satellite communications, even the internet. These systems rely on the current positions of the Earth's poles. A pole shift. That throws everything into chaos.
No more Google Maps. No more instant communication. No more funny cat videos. That's a level of chaos I don't think we're ready for.
Maybe not quite that dramatic, but yeah, you get the idea. Navigation would become a huge challenge. Communication systems could be severely disrupted. Imagine the impact on global trade, travel, even just keeping essential services running.
It's like the whole world suddenly going offline. Except it's not just our devices that are affected. It's the very fabric of our modern world.
And then on top of that, think about the social and political ramifications. Imagine mass migrations, resource scarcity, this intense competition for survival, this kind of global upheaval. It has the potential to completely redefine the world as we know it.
So we're not just adapting to a new environment. We're talking about navigating a world where the very foundations of society have been shaken.
Exactly. There's a very real potential for conflict, for instability. We could even see the collapse of current power structures.
Deep divers. This is where things start to get really, really real. But hey, let's not spiral. We're still exploring hypotheticals here. We're trying to understand the possibilities, not predict doom and gloom.
Right. We're all about approaching these possibilities with a healthy dose of curiosity and a willingness to question what we think we know.
So instead of panicking, maybe we should be asking ourselves, what can we learn from all of this? How can we prepare? How can we make ourselves more resilient to these kinds of potentially catastrophic events?
That's the spirit. Now, in that spirit of open-mindedness and exploration, let's shift gears a bit. Are you ready to dive into some of the, shall we say, more fringe theories about pole shifts? Get ready for some truly wild ideas.
Welcome back, deep divers. We've gone from the science to the historical mysteries to even some pretty out there ideas.
That's right. And now it's time to get even more adventurous. We're stepping into the world of fringe theories.
Those ideas that might seem a little unorthodox, but hey, sometimes those outside-the-box perspectives can spark some fascinating insights, right?
Okay, I'm ready for some mind-bending. Lead the way.
All right, so one figure you'll encounter in this territory is a scholar named Immanuel Velikovsky. Now, he proposed some pretty radical ideas about what are called planetary encounters.
Planetary encounters, like planets actually bumping into each other. Isn't that the plot of a disaster movie?
Well, Velikovsky believed that Earth has had some close calls with other planets in the past, like Venus and Mars. And these close encounters, he said they caused all sorts of catastrophic events, including, you guessed it, pole shifts.
Okay, that's definitely a theory that's going to turn some heads. But what kind of evidence did he use to back up these claims?
Velikovsky drew on a whole range of sources. Ancient myths, legends, even geological and astronomical data. He saw these close encounters as leaving a huge mark on human history and culture. So like maybe those ancient flood myths, were inspired by an actual close encounter with another planet.
That's one way to look at it. Velikovsky's theories. Let's just say they weren't exactly embraced by mainstream science, but they definitely sparked a lot of debate, which is always a good thing.
I bet. It's like a cosmic game of billiards, but with planets. Speaking of intriguing figures, what about Edgar Cayce?
Ah, yes, Edgar Cayce, the sleeping prophet. Now, he was an American psychic who claimed to receive all kinds of visions while in a trance.
Hold on, a psychic. So we're talking about psychic readings predicting pole shifts. This is getting more and more interesting by the minute.
Cayce had a lot to say about Earth changes. He talked about shifting poles, massive geological upheavals. He even gave timelines for some of these events.
So any of his predictions come true? Did he nail any of those timelines?
Well, interpreting Cayce's readings can be pretty tricky. They're often full of symbolism, open to different interpretations. Some people see connections between his readings and real events. Others aren't so sure. It depends on how you interpret things, really.
I'm starting to see a theme here. A lot of these predictions are kind of like looking into a crystal ball. It's all a bit open to interpretation.
You're right. It's more about getting us to think in new ways, to question what we think we know. These guys were exploring big, profound ideas with the tools and knowledge they had.
Okay, fair enough. But let's bring things back down to Earth for a moment. What's the mainstream scientific view on all of this? I mean, what are scientists actually saying about the chances of a future pole shift?
While scientists are always keeping a close eye on things, they monitor the Earth's magnetic field, the rotational axis, looking for any big changes. And yes, there have been shifts in the magnetic poles, that's true. But for the most part, those are seen as normal fluctuations.
Should we be worried about those magnetic shifts? Could those be a sign of something bigger brewing?
That's a great question, and scientists are actively trying to figure that out. The Earth's magnetic field is complex, always changing. We're still piecing together how it all works.
It's a bit of a wait-and-see game.
In a way, yeah. But I think the biggest takeaway from all of this is that Earth is a dynamic, ever-changing planet. It's not static. It's constantly evolving and reshaping itself.
It's a good reminder to stay curious and keep an open mind.
That's what it's all about. That's the beauty of science. It's a journey, not a destination. We're always learning, always discovering.
Well said. We've covered a lot of ground in this deep dive.
One of the most fascinating pieces of evidence comes from this independent researcher. His name is Mario Bildreps, and he did some analysis, like serious analysis of the orientations of, get this, over 1,200 ancient pyramids and temples from all around the world, thousands of years, tons of different cultures.
Hold up. Pyramids, like the ones in Egypt. What do pyramids have to do with pole shifts?
Here's the thing. Bildreps found out that these ancient structures, they kind of align with different places where the poles might have been in the past. It's almost like they built them on purpose to point towards these shifting poles over, well, like hundreds of thousands of years.
Wait, slow down, slow down. Are you suggesting that ancient civilizations, like, they knew about these pole shifts and they built their monuments accordingly? That's kind of crazy, isn't it?
It is wild, right? But let's not jump to conclusions too fast. The alignment is there, no doubt about it. And it definitely raises some pretty intriguing questions, like what were these ancient cultures capable of, you know? What did they know about the Earth that we're just, like, figuring out now?
Okay. My mind is officially blown. So we've got pyramids pointing every which way, kind of hinting at where the poles used to be. But how does Greenland fit into this whole thing?
Well, get this. One of those points of alignment, you know, the ones that suggest where a pole was in the past, it sits right over Greenland.
You're kidding, right? That's mind-boggling.
Mind-boggling is a good word for it. It makes you rethink everything you thought you knew about, you know, Earth's geography and history. And it opens up all these new ways to understand the changes that we're seeing in Greenland today.
Okay, I'm hooked. I'm totally hooked. But before we get too carried away with pyramids and continents doing the shuffle, let's look at some other evidence, right?
Yeah.
Anything else that points to these dramatic shifts in Earth's past?
Oh, absolutely. We can turn to a source that's, well, a bit more on the scientific side, but equally fascinating. Ready for this? Ice cores. Specifically, ice cores from Antarctica. They've shown some really surprising temperature variations over time.
Ice cores? You mean those frozen time capsules from, like, the polar regions? What kind of secrets have they been hiding?
Those cores, they hold a record of Earth's climate history going back thousands of years. And when scientists analyze the temperature proxies they find in these cores, it shows that the temperature swings in the past, well, they've been way bigger than what we've seen in, say, the last 2,000 years.
So you're talking about some seriously extreme temperature changes, right? And these fluctuations, they were happening way before humans.
Exactly. These are natural variations in temperature. And they tell us that Earth's climate, it's a dynamic system, always changing, even without us humans getting involved.
Okay, got it. So we've got these extreme temperature swings in the past.
Yeah.
But how does that connect to our pole-shifting pyramids? What's the link?
Well, here's where it gets really interesting. Those periods of extreme temperature change, they seem to line up with the periods of crustal deformation. You know, the ones that Bildrup's research suggested.
Wait, hold on. You're saying there's a link between massive shifts in the Earth's crust and these major global temperature fluctuations. And these shifts could, like, be connected to what we're seeing in Greenland.
That's the theory, yeah. And it's pretty compelling, don't you think? If the Earth crust can actually shift as much as this research suggests, well, it makes sense that it would have a huge effect on global climate patterns, including, places like Greenland.
This is getting more and more intriguing by the minute. But I gotta be honest, I'm still trying to wrap my head around this whole idea of the Earth's crust moving that much. Is there any other evidence out there that backs this up?
There is. And this next piece of the puzzle, well, it might be the most unexpected yet. It involves a secret military mission in the Arctic during the Cold War. We're talking about the 46th 72nd Reconnaissance Squadron.
A secret military mission. Now you're talking. This sounds like something straight out of a spy movie.
It does, doesn't it? So picture this. It's the 1940s. Tensions are high between the U.S. and the Soviet Union, right? The U.S. military, they send this squadron to Alaska. Seems like a simple task. Map the Arctic.
Map the Arctic. What's so secretive about that?
Well, during their flights over the Arctic, the squadron, they made some pretty remarkable observations about the Earth's magnetic field.
And what did they find? Don't leave me hanging.
They found evidence that there wasn't just one magnetic pole, but three.
3 magnetic poles. Hold on, that just throws everything we thought we knew about the Earth's magnetic field out the window, doesn't it?
It sure does. It really challenges how we think about it, and it raises these really interesting questions about the connection between, like, crustal deformation and those weird things we see in the magnetic field. If the Earth's crust is really shifting as much as this theory says, then yeah, it would make sense that it would mess with the magnetic field too.
Okay, my mind is officially blown. Ancient pyramids, ice cores, a secret military mission, and now 3 magnetic poles. It's putting together this giant cosmic puzzle. But before we try to solve it, there's one more piece we got to consider. And it might be the most controversial of them all.
Ah, yes. You're talking about the growing Earth model?
You know it. Some researchers are saying that the Earth isn't just shifting its crust, but it's actually getting bigger, like expanding in size. They say this expansion, that it could explain continental drift, changes in where the poles are, maybe even how mountains and oceans formed.
It's a bold idea, that's for sure. And while it's not exactly mainstream science, it's important to look at all the possibilities when you're dealing with something as complicated as the history of the Earth.
Exactly. Some of the evidence for this theory is pretty compelling, like those things that look like stretch marks on the moon, Mars, and other planets and moons. And of course, there's the fact that the Earth's rotation has been slowing down over time.
Those are interesting points. But there are some pretty big challenges to this whole growing Earth model. For one, it's not clear where all the extra matter is coming from.
Right. If the Earth is actually getting bigger, where is all that extra stuff coming from? So
right.
It breaks the laws of physics as we know them?
That's the million-dollar question for anyone who believes in the growing Earth theory. And it's a question that no one has really answered convincingly yet.
All right, so we've got all these pieces of the puzzle. Possible pole shifts in the past, maybe links between those shifts and big temperature changes, and even this mystery of the multiple magnetic poles. But let's bring it back to the main question here. Could a pole shift have something to do with the changes we're seeing in the Greenland ice sheet today?
That's the big one, isn't it? And it's one that we're going to explore in a lot more detail in the next part of our deep dive. We'll dig into the specifics of the Greenland ice sheet, look at the evidence for why it's melting, and talk about what could happen if it keeps shrinking.
Don't go anywhere, deep divers. Our journey into the mysteries of our planet, well, it continues in just a moment.
Welcome back, deep divers. Ready to dig a little deeper. In this part, we're gonna take a closer look at the evidence for this whole true polar wander thing. The theory that the Earth's crust can actually shift and move those geographic poles around.
I'm still trying to wrap my head around everything we talked about in the last part. I mean, pyramids as signposts for past poles, ice cores showing those crazy temperature swings, and then there's that secret military mission that found, like, 3 magnetic poles. It's wild to think that all these, like, seemingly random things could be connected.
It is fascinating, isn't it, how all these different pieces of the puzzle start to fit together when you step back and look at the bigger picture. And true polar wander, that's a concept that can help us connect those dots and, really understand just how dynamic our planet is.
Okay, so let's dig into the evidence. What are, like, the most convincing pieces of information that back up this theory?
One of the strongest pieces of evidence comes from the study of paleomagnetism. So you see a lot of rocks, they have these iron bits in them that can get magnetized, almost like tiny little compasses, frozen in time.
Oh, wait, so you're saying rocks have built-in GPS systems that tell us where they've been? That's pretty cool.
It is pretty cool. And these rock compasses, they can tell us a lot about where those rocks were in the past, relative to the Earth's magnetic field. And by studying the magnetization of rocks from different continents, different time periods, scientists have discovered something pretty remarkable.
What do they find? Spill the beans.
The direction of magnetization in these rocks, it often doesn't line up with where the magnetic poles are now. It's as if those rocks formed in a different place, like the continents themselves have moved over time.
Okay, that makes sense. But how do we know it's the continents that moved and not the magnetic poles? Couldn't those poles have just, wandered around on their own?
That's a great question, and it's one that scientists have, really thought about. The key is that the magnetic signatures in rocks from different continents, they don't all point to the same past pole positions. If it was just the magnetic poles moving, we'd expect to see a more consistent pattern. But what we see is that the continents seem to be moving independently of each other, which fits with the whole continental drift idea.
Ugh. Ah, continental drift. Now it's all starting to come together. But if we're talking about continents moving, that means there have got to be some seriously powerful forces at work down there, right?
Yeah.
What could possibly make something as massive as a continent change its position?
That's a question that's been puzzling scientists for ages. One theory is that it's all about convection currents in the Earth's mantle. That layer of hot, kind of gooey rock beneath the Earth's crust.
Convection currents, like the currents that make soup bubble on the stove.
That's a surprisingly accurate analogy. The intense heat from the Earth's core, it creates these slow-moving currents in the mantle. Think of it like, a giant pot of soup simmering away, and the continents are like croutons bobbing around on top.
Okay, I can picture that. But how do these soup currents, or convection currents, I guess I should say, actually move the continents?
Imagine the Earth's crust as these giant but incredibly thin plates floating on top of this churning mantle. These plates, they're called tectonic plates, and their movements are driven by those convection currents.
So it's like a giant slow-motion puzzle with the pieces always shifting and rearranging.
Exactly. And as these plates move around, they can bump into each other, pull apart, or grind past each other. These movements, they create mountains, volcanoes, earthquakes, and yeah, they might even contribute to true polar wander.
This is starting to sound less like a soup pie and more like, well, a geological demolition derby. But how does all of this tie back to Greenland and the idea that it was once a polar region?
If true polar wander is real, then any point on Earth could have been a pole at some point way back when. So yeah, Greenland, Africa, Australia, any of them could have been at the pole millions, even billions of years ago.
So Greenland's not the only one who's been doing the polar dance.
Right. And remember that research by Mario Bildraps, the one with the pyramids? It suggests that Greenland was probably in a polar position at some point, based on how those ancient structures are aligned.
Okay, got it. But what about those ice cores from Antarctica, the ones that showed those extreme temperature changes? How do those fit in?
Well, if the Earth's crust is shifting and moving continents around to different latitudes, that would definitely cause some big changes.
Ah, that makes sense. If a landmass moves from, like, the tropics to a polar region, it would get a whole lot colder and vice versa. It's like moving from Miami to Alaska. You'd need a whole new wardrobe.
Exactly. And those changes would show up in the ice cores, which, like we said, hold a record of temperature changes over thousands of years.
It's incredible to think that these ancient processes could have such a huge effect on climate. But I have to admit, I'm still having trouble picturing how something as massive as the Earth's crust could actually move that much.
It's definitely a tough concept to visualize. But remember those convection currents we talked about. They're incredibly powerful forces, and they've been operating for millions and millions of years. It's like that saying, give it enough time, even a tiny drop of water can carve a canyon.
So those seemingly small movements in the mantle, they can add up over time and eventually lead to these huge shifts in the continent and even the poles. It's amazing to think about the timescales involved here.
It is. We humans, we think in terms of human lifetimes, but when we're talking about geology, we got to think much, much bigger.
Okay, so we've established that true polar wander is a serious scientific theory with a lot of evidence to back it up. We've also talked about how those shifts in the crust could have major impacts on climate. But, I want to go back to something we touched on earlier, the growing Earth model.
You're not going to let that one go, are you?
I can't help it. It's such a mind-blowing idea, the Earth actually getting bigger. What do people who believe in this theory say is causing this expansion?
Well, there are a few different ideas out there. One is that the Earth is collecting matter from space, like cosmic dust, or even bigger things like meteoroids.
So the Earth is like a giant vacuum cleaner sucking up stuff from space. That's a pretty cool image.
In a way, yeah, but the amount of stuff we get from space is pretty small, so it's probably not the main reason for the expansion if the Earth is actually expanding, that is.
Okay, so what are some other possibilities?
Another idea is that matter is somehow being created inside the Earth itself. This one's tied to some less conventional physics theories, but it's worth noting because it challenges how we currently understand the laws of physics.
It definitely makes you think. If matter is being created inside the Earth, where is it coming from? It seems like that would break some fundamental rules.
That's the challenge for anyone who supports this theory, to explain how matter could be created inside the Earth without contradicting the laws of physics as we know them.
It's a tough one, for sure.
Yeah.
But I guess that's what makes this whole topic so fascinating. We're really pushing the limits of what we know about the Earth and its history.
You're right. And even if the growing Earth model turns out to be wrong, the fact that scientists are even considering it shows how much we still have to learn about our planet. Greenland is at a similar latitude to parts of Alaska and Canada and Russia. But those places aren't totally covered in ice. Even Iceland, which is closer to the North Pole, isn't completely iced over.
Yeah, it's like Greenland is this giant freezer in the middle of a pretty normal neighborhood.
Yeah.
Wow. This deep dive has taken us on a wild ride. Ancient mysteries, mind-bending scientific theories. It's been an unforgettable journey.
It's been great exploring these fascinating topics with you and all our listeners.
And to our amazing listeners, thanks for coming along with us on this incredible adventure into the unknown. We covered a lot today, from ancient pyramids and pole shifts to melting ice sheets and the mysteries of Earth's past.
And if you enjoyed this deep dive and want to explore more mind-blowing mysteries with us, don't forget to hit that like button and subscribe to the channel. We've got a lot more deep dives planned.
And remember, the journey of discovery never ends. Keep asking questions, keep exploring, and keep diving deep into the mysteries all around us. Until next time,